We are very, very pleased to have all of you with us here today. My name is Amy Christensen, and I'm the founding executive director of the Sun Valley Institute up in Sun Valley, and we are very honored to be co-organizing this event with our friends at Warm Springs Consulting. Just to give you a brief on both of us, I think a lot of folks were, who's pulling this together? What's the goal here? We founded the Sun Valley Institute in the wake of fires and snowfall changes and some of the impacts that we've been seeing economically also with our economic downturns, to be an institute to build what we call lasting quality of place, to turn the risks that we face into opportunities, which is exactly what we're talking about here today. How do we turn our energy risks into energy opportunities? And Warm Springs Consulting is a sustainability consulting firm in the Intermountain West. So those are your two co-organizers of the event today. But really this is about our speakers and about the topic in front of us. It's an incredibly exciting time in energy all over the world and energy here in Idaho. Not only do we have incredible assets, renewable energy assets, we also have knowledge and expertise in the form of Idaho National Laboratory, power engineers, some of our folks here. We're very fortunate to have based here in Idaho, and so how do we turn those opportunities into real benefits for our state? That's what we're going to talk about today. We're going to start with Kate Gordon. Oh, before I go there, let me just point you to some of the links in the handouts. So for more details about all of these topics, the third page of the handout has the links to various articles that we thought would be helpful to folks. Also, we are doing a podcast today, and so thank you to Wild Lens and their podcast, Eyes on Conservation. So that'll be available afterward for folks who weren't able to be here. We're also filming it in the back, and that'll be available on our website at Sun Valley Institute as well. So folks can watch afterward. And finally, there was an article that I authored in Idaho Business Review on Friday about energy resilience, specifically providing some deeper background about those risks and opportunities that we are going to discuss today. So that's also in your links list. So with that, I would like to introduce our first speaker. Our first speaker is Kate Gordon. Kate is the founding director of the Risky Business Project, which was a very powerful collaboration of business and economic experts around the risks and opportunities facing the United States business sector from climate change. And Kate has a long background in economic development at the local and state level, as well as the national and global work that she's done with the Risky Business Project and others. She is an advisor to the Paulson Institute, and she is also a non-resident fellow at the Center on Global Energy Policy at Columbia University. So with that, I'm going to turn over the dais to Kate, and then we'll hear from our speakers, and then we'll have about a half an hour of Q&A for everybody that will moderate afterwards. So thank you, Kate. Yeah. You're joining us. All right.
Thanks.
That's set up. I'm going to hand over the mic.
Okay, even if I can't see them. Right, so I should use the arrows.
Yeah.
Okay. Thank you, everybody. Just trying to understand what is on this slide deck. I recognize some people in the room from last night, and where I gave this talk, but to a kind of a bigger public audience, and you'll see some similar things, but I'm going to kind of shift the focus a little bit, given this group. Well, thank you for inviting me, Amy, and also Deb and Warm Springs, and it's great to be here. I actually really like being here in Idaho talking about these issues, which I do talk about all over the country, and increasingly also in China, where I've done a lot of work. So we can talk about that in the Q&A if you want to talk about China. So as Amy said, we're really here to talk about risk and opportunity. I'm going to really focus on sort of the physical climate risk side of climate change and climate impacts in Idaho. I think others on the panel will be more focused in on very specific opportunities. I'll touch on a little bit of opportunity. I think some of those same things that make Idaho at risk are also potential opportunities. So we'll talk a bit about that. I think we're used to, in the climate world, talking about risk and impacts in terms of kind of climate science. And you've all probably seen some version of this chart. This is just essentially here's where we are now. We have to get off our path and on another path, or else we will get to far greater levels of global warming than we can handle as a society and as an economy. You know, I find this useful just as a reminder, but I also often find it sort of inaccessible. I think the scientific community is getting a little better about communicating the impacts. The most recent, I don't know if people saw it a couple of days ago, the International Panel on Climate Change came out with their report that was commissioned by governments on what it would take to get to 1.5 degrees. You may remember from the Paris Agreement that global agreement was to get to significantly below 2 degrees, but many of the island nations facing kind of this most severe impacts asked for 1.5 report, and this report just came out. The scary thing about this report is it basically says we only have till 2040 to take serious action to get below 1.5, but it also says that past emissions are already there and are already causing impacts, and those two things are both important for what I'm going to talk about. One, we need to act now, but two, we also need to think about existing emissions in the atmosphere. I think those existing emissions are an opportunity for Idaho, so we'll talk about that. Most of my work has been about translating from that climate science and very, very data heavy and kind of apocalyptic scenario, global level work into very local economic impact work on climate impacts. And particularly, a lot of the work I've done has been through a project. This is from the Task Force on Climate-Related Financial Disclosures, which was headed by Mike Bloomberg. I did a lot of work with Mike Bloomberg before this and leading into this on a project, as Amy said, called the Risky Business Project, which was co-chaired by Hank Paulson, the former Treasury Secretary, by Tom Steyer back when he was at Farallon Capital, and then also by Mike Bloomberg, with a number of people on that board, including former CEOs from Cargill, Caterpillar, Walmart, and a number of other companies. Xerox. We worked together to basically do a two-part thing back in 2014 and through 2017, which was to build out a very robust model of what physical climate impacts would look like in the United States at a granular county level of data. I said last night we used about 20 terabytes of data on that project. Very granular. I'll show you some maps in a minute. And then we also then looked at what does that mean for specific sectors of the economy, including energy demand as well as agriculture and coastal property. That work, we in that work really focused on physical climate risk. The Task Force on Climate-Related Financial Disclosures, which has brought this idea of risk in climate change and thinking about it from an investor standpoint to kind of the global conversation, really lays out three kinds of risks that I think are important to keep in mind. Transition risk, which is what's the risk that you don't transition? What's the risk that as we transition globally to a low carbon economy, regionally to a low carbon economy, that your company is not transitioning or the companies you're investing in are not transitioning? That risk can be stranded assets, it can be just technology slowdown, it can be a bunch of things, it could be just being eclipsed by other companies. I always think of it as you could be either MCI or AT&T when the cell phone came in, right? I mean, I'm old enough to remember the MCI long distance calls. MCI did not make it, they didn't diversify, they didn't go into cell phones, AT&T did. Physical risk, which I'll talk about a bit more, which is really the physical climate risk on things like supply chains and your core business operations. And then, of course, there's litigation risk, which is the third one. It's not up here, but it's the third obvious one. I find this chart is extremely, investors really like this chart. So in the Risky Business Project, we looked a lot at physical climate risk. And this is a map. It kind of shows you the granularity. You can see that the individual spots here are all county level. This is just a heat map for the course of essentially from the day the report came out in 2014 all the way through the end of the century. It's for the baby in the first slide is a baby born the day the report came out, so it's their lifetime basically. And you'll see in this, you might think to yourself, oh, the Northwest looks pretty good in this heat map. For sure compared to places like the Southeast, that is true. I'll get into more specific Idaho risks that aren't really captured in this map, but I did want to put a pin here and say, the fact that the Northwest looks pretty good in these heat maps is an opportunity for this state. There are companies all over the place and companies and states looking for manufacturing in particular that happens in states where there was low carbon energy sources and where the extreme weather is not going to be a big deal. Those kinds of companies are starting to look at the Northwest in particular and also the upper Midwest as they're thinking about expanding operations. So it's something to think about as an opportunity. But it's not entirely an opportunity, it's also a risk. You know very well that wildfires are one big risk. I'll talk about that. But essentially, Idaho may not be as warm as some places, but it's getting warmer. We are going in this state from an average of 5 days a year over 95 degrees to between 18 to 42 additional days over 95 degrees every year. by end of century. That's a big range because, like with everything in climate change, it depends on how much we emit into the atmosphere in that time period. But you could see up to, that's a likely range of up to 42 additional days. So up to about 45, 46 days over 95. That's a significant difference for this state. So the numbers are just going up. This is from Climate Central. That has specific economic impacts. One of them is labor productivity. For those of you who are in utilities or in other outdoor activities, forestry, some transportation, some manufacturing, where you're in agriculture with outdoor workers, this is an impact you will see. As those days get hotter, it's much harder to do that work during the day. And that's something that we found in our analysis was one of the biggest economic impacts of the United States, was the decline in labor productivity. But you're probably more used to thinking about wildfires, which are, of course, already happening, already an impact you're feeling, significant impact on this state, not only the timber industry, which is $2.3 billion a year to the state, but also, of course, to disruptions in energy supply and the grid. This is where Idaho ships its products for wood, so it's a big market. Agriculture, I won't talk about too much. I don't think there's too many people in the room who are ag-focused people, but agriculture, extreme heat does lead to agricultural yield increases in some crops, but decline in a number of others. This state, of course, ships all over the world. When it comes to products, that's another economic impact. And then, of course, I think one of the biggest ones for this group, which is decreased snowpack, which we're pretty confident about. We're pretty confident about the modeling that's about heat and heat-related impacts. The modeling on precipitation is much harder and much less clear. What I can tell you is that there will be more or less. There will be a lot more rain or a lot less rain. It's all extreme. I can't tell you which way it'll go consistently, but it will be more extreme, and snowpack we do see decreasing. What that means in a state like this is that summer water availability is lower when that snowpack is lower. That obviously has a huge impact on hydropower in particular and the variability of hydro resources. That's something you'll hear more about from Idaho Power, but this is Idaho Power's most recent sustainability report with an adaptation section, which actually calls this out for the first time, saying we are looking at snowpack data, we are looking at precipitation data, we are trying to figure out how to better predict that, but also we're starting to think about how to potentially build up and back up the system in order to deal with that variability. And I think that's another big opportunity for this state in terms of backing up that system with more distributed renewables, for instance, which are less susceptible to these big extreme events. The last thing I'm going to say is just on a couple other opportunities I want to highlight. This state is very land-based and place-based. A lot of the resources are natural resources. That means the state is at risk from physical impacts, but it also leads to opportunity. A couple things I just always like to highlight. One is cross-laminated timber. It's as the world, and in particular the Western market, California and the other Northwest states, decide to move from high carbon products like steel and concrete into things like cross-laminated timber, it opens up a lot of market potential for Idaho. I think there's opportunity for the state to lead on that issue. You're already one of the first states manufacturing it. There's a lot of opportunity in energy, particularly, as I just said, in diversifying the energy base, in thinking about storage, as you'll hear a lot more about, as a key piece of that. And then at some point, we may actually have a Western interconnected grid. California just passed a law requiring 100% clean energy by 2045. They are going to have to get that from somewhere. There's a lot of opportunity in your access and proximity to the Western markets, as well as to the Pacific Rim through the Western ports. So I'm going to leave it, I think, at that. This is just Hank Paulson being inspirational about how we can solve problems. I will say just one last thing about Hank, which is that he, and I'll stop after this, he's been on TV a lot because it's the 10-year anniversary of the financial crisis, as I'm sure you all know. He was just on Bloomberg News, and I would watch this if you have a chance, talking about the crisis, and they asked him about climate change, which he identified as the next big crisis. And he said, the thing is that unlike the housing bubble, we can see climate impacts coming decades away, and we need to be preparing for it. It's easier than it was then to prepare. So I think that's just worth thinking about as you're doing business and planning. And that's my email if you want to get in touch with me, and our websites, and there's tons more information, and I'm going to stop there.
Thanks, Kate. I'm going to call up Todd Haynes, and Todd will get you mic'd up here. Todd is the Renewable Energy Project Manager at Power Engineers. And Todd's experience in storage, actually I thought this was very interesting, in energy storage, which is so important as we talk about the future of the grid. Todd's experience with energy storage started in 2004 when he was completing his mechanical engineering master's at Boise State. And was looking at how to make wind power more efficient and realized the integration of the grid was a critical issue and storage had to play a critical role. So we've got the right guy for the job to join us here today. Thanks, Todd, very much.
Thank you. Let's see, I better start my stopwatch so I keep myself from talking forever. Well, thank you very much. Thanks for inviting me. I appreciate it, and thanks everyone for coming out. What I want to do today is, I definitely want to talk a lot about the opportunities because we have a ton of opportunity in Idaho. But before we get into the opportunities, I just kind of want to set the stage by talking about the transition of the electric industry. That transition's going on right now, and I just kind of want to lay it out a little bit. Go. Okay, there we go. So before I do that, though, a little background on Power Engineers. Power is a local company. We were formed here in, actually in Pocatello in 1976 when a couple of engineers from Idaho Power decided that they wanted to strike out on their own. And as you can see, we've grown quite a bit in 40 plus years. Now we've got more than 30 offices across the nation, 3,000 employees. So what I want to point out by this, though, is that we work for virtually every large utility in the nation. And because we work for virtually every large utility in the nation, we've got a really unique perspective on the energy transition that's going on across the country. And so I just kind of want to bring some of that perspective into the conversation. So where are we coming from? This is kind of a high-level picture of the 20th century grid. And in the 20th century grid, it was pretty much one way. So we had a big centralized power plant that was located outside of town somewhere. It might have been 50, 100 miles outside of town. That could have been coal, nuclear, hydro, but a big, large plant made all the electricity, sent it in on high voltage transmission lines, and these would be, maybe tens or hundreds of miles. Once it gets into town, goes to a substation where it steps down in voltage from high voltage to medium voltage, and then these are the distribution lines. And this is what we see around town. The distribution lines bring the electricity to our homes, to our businesses, and then you can see that down here, and it steps down in voltage again to a lower voltage that we use in our homes and businesses. And we'll point out that at Power, we design all of these systems. So we're very familiar with all of these systems, and again, how they're transitioning around the country. I guess, let me see, one thing I forgot to point out on this. This, comparatively, the old system, compared to where we're going, was much simpler to control. It was simpler to control because the utilities just needed to forecast how much electricity we were going to use. They forecasted load every day. They knew, okay, how much, it's Monday morning at 8 o'clock, we know how much you're going to use, we know how much you're going to use on Saturday, Sunday, whatever. And so by forecasting only the load, they were able to generate the electricity that we needed when we needed it. And they kept the electric grid in balance, and it was a much simpler proposition then. Now we transition to the 21st century, so this is where we're going. To a certain extent, all of these various elements exist in various parts of the country. I don't think there's anywhere in the country yet where it's all there and it's all working together. But this is the 21st century grid, and it's going to look a lot different than the 20th century grid. So we still have the centralized generation. Our centralized generation now includes large utility scale wind and solar. And we see that in Idaho, and we see that around the country. So you've got large scale wind and solar, they're connected in at high voltage, still coming in and being brought into town. We've also got storage, and you can see I've got storage throughout here. Storage is not always batteries. There's a lot of different types of storage technology. Just take this icon to be some type of storage, and we can talk more about the different forms of storage later and their pros and cons. But as you can see here, we can have, on the utility scale, there can be storage located with your large PV plants, PV solar. Then it comes down to the distribution grid. In the distribution grid, now we might have some neighborhood storage, And then when you get down to the individual consumer level, we have solar on rooftops, we have some storage, and all of this now is working together. So before we had one-way power flow coming out to the end user. Now we've got power flowing in multiple directions. So you might have, at a house, you've got somebody generating a lot of electricity during the middle of the day, but they're not home using that electricity. So that electricity is now flowing back to the grid. At the same time, there's electricity flowing into town, so it's coming in multiple directions, and it becomes it's just a much more complicated system now. We can see the benefits from this, though, across the board. So benefits of large wind and solar come to maybe the landowners, the ag plants, farmers that have the wind can get more economic benefit on their land. Benefits of the storage there. You can store the electricity that's made at times when it's not needed and then deliver it to the grid when it is needed. On the distribution scale, so this is around your neighborhoods, the storage can benefit the grid by helping to maintain the voltage and the frequency that the grid needs to stay in balance. And then on the home level and the business level, you've got storage, and that has different benefits again. So maybe a residential customer, they're generating electricity in the day, come park their electric vehicle at night, plug it in, and they can use that battery to charge back their EVs. Industrial customers, they're typically paying a demand charge. If you're not familiar with a demand charge, they pay for how much electricity they use plus whatever the peak demand is over the course of the month. And so if they've got storage and solar, they can lower their demand charges by utilizing the stored energy when all their pumps come on or when all their big load is, and so they can reduce their costs. So you can see that the storage has different benefits across the grid, and different users realize those benefits in different ways. Again, this is more complicated to control, just because there's more now to think about. The utility company is no longer only thinking about the load and how much load are we going to need tomorrow. We're now thinking about what's the wind going to do tomorrow? Is there going to be cloud cover? Are the solar panels going to be available or not? That's a big question. If you've got a whole lot of solar, rooftop solar, but none of it's available, then that doesn't really help the grid. So there's a lot more complication here. And again, I'll point out that power works on virtually all of this stuff except the residential. We don't work with any residential. But we are very familiar with the other elements. Okay. Another key element to the grid of the 21st century is microgrids. Microgrids are kind of just what it looks like. So if the power goes out, say there's an event, say there's a storm, hurricane, a wildfire, whatever, the grid goes down, you still need to keep your critical loads. Maybe this is a hospital, still needs to have power. So in the old days, we've had just diesel generators, and we still use diesel generators, but now we can also use photovoltaics, and we can use batteries, and keep that power flowing to the critical load as long as it's needed until the power gets restored. And I need to grab water. Thanks. Okay, so this is the most complicated slide, and by design. The last couple slides I was depicting energy flowing. Now we're depicting communication flows. And I've been kind of leading up to this by talking about how the grid was easier to control in the 20th century. 21st century, it's more complicated to control. And the reason is that, if you look at all these various elements that are now on the grid, think of them as instruments. Think of them as instruments, and if you've got a whole bunch of instruments and they're not playing together, it might sound like the first day of junior high school band. But if you get all of your instruments playing together and you've got a good conductor leading them, now you turn it into a symphony. And when you get it playing together as a symphony, it all works well. And that is what this acronym is. As a good engineer, I have to throw out a new acronym, right? So DERMS is your acronym of the day. Distributed Energy Resource Management System. This is the conductor of the symphony. And so what's going on here is you've got all these different elements. So, this might be a house, and you might have demand response, which is like here in Idaho Power, we've got the AC cool credits. That's an example of demand response. Maybe you've got an electric vehicle charge that needs to charge. You've got some solar on this business. And so these can be businesses or houses. This can be neighborhood scale, and then again, distribution and transmission. All of these various elements come with their own control system, right? And everybody's control system, oh, it's great, it's smart, it's plug and play, just plug it in and you're ready to go. Not true. Everybody's got a computer, everybody's heard that story. We know that it's not true, it doesn't work that way. So in order to make it work that way, that's what the idea of DERMS is. And it's a very complicated proposition, but you want all these individual elements that were built by different manufacturers, and they have their own different control systems, to communicate the same language, to play well together, and ultimately to help out the utility, whether it be Idaho Power or anybody else, to be able to integrate all these various resources and keep the lights on and give you the power when you need it. And so this is where a lot of innovation is going on right now. At Power, we work in this field. This is new to us. We are good at integrating utility scale. We've got a lot of experience with it, but just like everybody else, this is a new realm, and this is kind of where all the innovation is going. And I think that's everything I had to say.
Thank you. Next we have Kurt Myers. Kurt's Renewable Energy Manager over at Idaho National Laboratory. Long time working in this area of renewable energy, microgrids, and storage. Really excited to have INL with us. They're such an asset to our state to have that expertise. About a couple years ago, went over to INL to meet and realized that about a third of their budget is actually focused in this arena. So it's a really exciting opportunity. We have them here in Idaho for us, and they also work with local communities, sometimes for free, as they did with our community on a digital electricity blueprint that's been really valuable to really understand our electricity system. So thanks, Kurt. Thank you. Welcome. Let's get this on here. Okay, work great.
Do you have that? Do you have that pointer?
Yeah, absolutely.
This one here. Okay, thanks for the introduction, Amy. I'm Kurt Myers again from the Idaho National Laboratory, and I'm going to talk a little bit about what some of our work there at the laboratory, what we get involved in, and you'll see a lot of parallels with what Todd was kind of talking about, getting into controls and systems integration and some of the characteristics of the types of systems that we're trying to integrate. I'll also talk quite a bit about energy security and resiliency aspects, which is a big portion of the reason why we got involved in this type of work many years ago. And looking for opportunities in the future from Idaho, what we see is a lot of what we've been doing for 20 plus years with the military, we're starting to see happen in private industry and in utilities, and they're starting to consider some of the same things that we've been dealing with and thinking about for a lot of years with the military work. So hopefully you'll find this interesting. Just a quick overview. I won't spend a lot of time on some of these, but just gives you a little bit of background. I think are we going to post the slides for people to look at on the website in the future? So there's some material in here that I'll gloss over and you can look at later on to delve into more of the details. But again, the INL is one of the head nuclear laboratories within the DOE system. And we have, you can see the blurb there talking about our advanced test reactor. There's been, I think, over 50 different reactors that have been put into the laboratory over the years to research and develop new technologies for the nuclear space. But I wanted to kind of focus on the last couple of bullets here. We're one of only 10 multi-program national laboratories that's within the Department of Energy system. And what that means is we work on a lot more things than just nuclear energy at our laboratory. And in fact, in my area, I cross over with the nuclear folks from time to time, but most of the time we're working on things totally different than nuclear energy. We're also the largest DOE laboratory. A couple of little photos there of our in-town complexes, the top part there. We're in the process of adding some more buildings related to cybersecurity work and homeland security types of work scope. And then the bottom one is the 890 square mile site that's out west of Idaho Falls, out on the desert. And you can see the various different facilities that are out there. Materials and fuels complex, where a lot of the research and development and analysis of nuclear fuels goes on. SMC, specific manufacturing capability, that's actually where the armor for the Abrams tank is manufactured. So a lot of people don't know that about the INL, that there's those types of activities. Naval reactors facility, a lot of the reprocessing of the nuclear fuel for the Navy goes on out there. And then our other facilities there, ATR, where the test reactor is, they brought on some, re-brought on the TREAT facility, which is another type of test reactor for transient events in nuclear systems. Critical infrastructure test range, we have our own, we're one of the few DOE laboratories that has our own power utility, Scoville Power and Light, and so we have engineers and linemen that operate and maintain a 60-mile transmission loop around here, and then we have multiple substations and distribution systems. So down here we actually have taken some of that power systems infrastructure, where they've taken out some of the older infrastructure and repurposed that into large power systems test bed capability. So there's a lot of homeland security work that goes on out there, and we're positioning ourselves to take some of the smaller test bed things that we're doing in town and transition those to larger scale R&D systems out on the power grid test range. Talking a little bit about some of our Department of Defense work. You know, we're working in islanded power systems, energy and power, a lot of energy storage, clean energy integration, a lot of systems engineering, data science and analysis, advanced materials and systems. On the clean energy integration side of the house, that's where I work. We have work in hybrid energy systems, geothermal systems, biofuels, electric vehicles, electrification of transportation systems, engineering and renewable energy integration. There's a quick slide on some of the homeland security work that goes on out there. A lot of cybersecurity, wireless test beds, some of the explosives test range things, so I won't spend a lot of time on that, but it kind of gives you a flavor for the broad multi-program laboratory aspect there at the lab. In my group, we've been working in microgrids and renewable energy, distributed energy systems for over 25 years now. A lot of this work started on, island grids where they had high-priced diesel, generated electricity, bringing in wind generation, solar generation, different types of storage systems, water production for fresh water. And it's really, mushroomed from there into a lot more activity in the microgrid space, not only on island grids, but on, grids within the continental U.S., missions overseas. We're doing quite a bit of work with U.S. RCENT right now with the Army on some of their energy systems over there, and trying to improve resiliency, improve the capabilities of systems, and just get more diversity and manage costs and fuel usage in these systems is really what we're working on. So this just kind of gives you a flavor. We've been involved in a lot of projects with the military, implementing renewables, battery storage, microgrids, backup power systems, and we get our hands dirty with a lot of different things. So, we not only work on renewables, we also dig into natural gas generation systems, combined heat and power systems, diesel, battery storage, and so we're looking at it from a perspective of security, resiliency, and availability to make sure that that particular mission or that base is going to have power when they need it. And when you look at it from the perspective of their utility service, Usually you're going to get, upwards of 3.5 to 4 nines of availability when you do a risk assessment calculation for the military. And for a lot of their missions, that's not good enough. They need backup generators, they need UPS systems. And what we found over the years that backup diesel generators are not always the best solution. They're not always as reliable as you'd want them to be. And just adding more and more diesel generators doesn't cut it, because then you don't have any diversity. What happens if something happens to your fuel supply chain? You can't get more diesel there. And we've talked about putting in more storage. Well, then you got to cycle through the fuel. Fuel goes bad. You can't just let it sit there forever. So generally, they only have 1 to 3 days of storage on a base. If they have a flight mission or something, they might have a lot more fuel around, but they're going to want to use that fuel for other missions besides just generating power in the event of a long-term outage. So we look at bringing in other resources like solar, wind, microhydro, waste to energy, all kinds of different things to try to add to the diversity and be able for them to run for longer periods of time in the event that they have a catastrophic outage that takes them out for. The Army is looking at least 14 days right now is their general metric. So, quick overview of microgrids. What is a microgrid? It's an integrated energy system consisting of distributed generators, energy storage, and or flexible loads, which operates as a single autonomous grid, either in parallel to or islanded from an upstream utility or other power grid. So that's a good definition to keep in mind for microgrids. And I'll let you read through the other bullets later on in the slide deck, but talks about why microgrids are of interest and what are some of the benefits. Really optimally manage distributed generations and energy storage and responsive loads. They can really help you when you're grid connected. You can use those for energy efficiency and economic, cost reductions for peak shavings, things like that. And then when you get into abnormal situations, you use those to provide power when the utility grid is not there and available for you. When you start talking about the economics of these systems, you really have to look at more than just the energy savings, the demand savings, things like that. When we do these projects for the military, we get in and we assess what's the cost that they incur when they do have an outage of different durations, and then we take that, we do a risk assessment and availability calculation, figure out how much improved they will be in terms of availability, and then use that as part of the economic business case. And I think you're seeing more and more of that start to happen outside of the military to figure out what those values are. And the value has a very wide range. It depends on what your application is, what your use case is. But we find in some of the DoD systems that sometimes that energy security value is worth way more than the energy and the demand savings that you get from that project. So just something to keep in mind that that type of resiliency and security can have a very high value assigned to it. And that's one of the main reasons why potential users want a microgrid, is because of that security and resiliency aspect. Also improves your knowledge of your system, what your use is of energy, and you get a better idea of how to optimize and become more efficient in your system operations. Lots of options on distributed generation. I won't talk too much about that. Kind of wanted to get into energy storage. That's been a big thing for us the last 5 years or so. Really seeing that come into the realm of possibility. In a lot of our systems now, it was kind of out of reach for quite a few years, but now it's really coming into the wheelhouse, and it's making things really exciting for microgrids and utility, integration and other aspects. So we're excited to be involved in a lot of that work. At our laboratory, we do a lot of testing on different battery systems. We have one of the electric vehicle testing programs for DOE and Department of Transportation. So a lot of experience in testing different chemistries of batteries, different types of cells and modules. At our lab, this is our microgrid, and the folks that are in Idaho Falls tomorrow will get a chance to see that. This is our microgrid test bed. I actually manage that system. We have a couple of flow batteries in the system. We've used lithium ion and lead acid and other types of batteries in the system before, in the past as well. But right now we're doing some R&D and testing work on this is a zinc iron flow battery system. We've done testing with the military on other types of flow batteries, vanadium redox and zinc bromine, finding some really interesting things as we go through that testing and research, and find out what needs to be improved in these systems over time. So I won't talk too much about flow batteries, but this talks about a little bit where the costs are headed, and a little bit on the efficiencies. The efficiencies are improving. Flow batteries are definitely not as efficient as lithium ion because you've got to run the pumps, to actively pump the electrolyte through the system. And you've got some, thermal management issues there, which you have with lithium as well, but generally not quite as prevalent. Todd mentioned there's lots of other types of energy storage systems, and we definitely consider those and research those in our activities. Flywheels, supercapacitors, lots of interesting technology trends in all those different spaces. Up and coming potential, we think that solid state is looking very promising here in the next 5-10 years or so. Flow batteries, and then some other chemistries, lithium metal, sodium ion. Lots of work in the lithium space on different types of anode structures and materials issues there. And really, this is kind of the big hitter slide here. Right now, the cost for utility scale energy storage, and we're talking, kind of 2 to 4 hours, maybe 5 hours type of duration here. You're getting costs getting down into the $450 to $600 a kilowatt hour range if you have a really large scale project. We're thinking that it needs to get down to about $350 to $400 a kilowatt hour and have 15 plus years of cycle life available for this to really start taking off. And it's already taking off, so it's getting very close to that. We've got a little bit of work to do in the cycle life capability, or drive the cost down to where the module replacement, at year 7 to 10 still gets you to this, end result life cycle cost number. So that's why you're seeing such activity, because it actually is getting close to that number. When you start getting medium and higher penetration levels of renewables and variable generation, that price is going to have to go down because you're going to have longer durations of storage. But for the near term, when we're talking about peak shaving, managing peak power, ramping events, stuff like that, that's kind of the number we're thinking. So, and I'll close it out there. Thank you.
Thank you.
Great. Next we have Mitch Colburn, who's with Idaho Power. Mitch has a major responsibility at Idaho Power, being in charge of planning and operations. Really looking, as I love what your bio says, leads an organization responsible for the energy future of the 1.2 million people that Idaho Power serves. So very big responsibility in leading the planning work there. And thank you so much for joining us, Mitch.
Thank you, Amy, and thank you for the invitation to be here today. Obviously, very impressive fellow panelists, pretty exciting, focusing on the future. That's my role within Idaho Power, the organization I'm over. And so just hearing, things that we're seeing today and setting up for the future, that's the realm I work in. And frankly, it's what really kind of gets me excited day to day, brings me into work. What's tomorrow look like for us all? So I am going to talk about kind of where we are today. So before we get to the future, I want to give some context to where we are today with our energy mix and then talk about some things Idaho Power is doing, starting to incorporate some of these new technologies and some things we see for the future. And then really focus on the future. What do we see coming, what's next, and how we're going to do this collaboratively. So just starting off, so Idaho Power, our decisions kind of are through three lenses. So we have cost or affordability, we have impact on the environment, and then our customers. So we don't have a business without customers. We are all consume electricity, but we definitely have to keep in mind customers, and a lot of customer focus, at least some of the things we're touching on today was the reliability element of our customers. So we want to provide a reliable service at an affordable cost, and obviously keep an eye on our environment as we do that. So those are the three lenses. Keep those in mind as I kind of walk through my slides. So I'll start with environment. This is a typical or average U.S. utility is 65% fossil fuel in their energy mix. You compare that to Idaho Power, our fuel mix, roughly 50% hydro, another 18+%. We call this long-term purchases, but that's because we, when we purchase the contracts, this is your hydro, your wind, your solar, there's some geothermal, but we purchase those from third parties, so we call them long-term purchases, and we sell the energy credits associated with those, the renewable energy credits associated with those, to the benefit of the customer. So collectively, 68% clean, so non-carbon emitting. Compare that, so we hear a lot about California and their ambitious goals. You compare Idaho and Idaho Power at 68% clean, average, this is a residential rate of roughly 9 to 10 cents. And you compare it to California, 44% clean with a rate of 17 cents. And so when we talk about affordability, it means different things in different states. So we start talking about adoption of some of the storage technologies and some of these new technologies. Affordability in one place is different than affordability in another. So just want to provide that context. Also want to talk about where we are today with CO2. So compared to 2005 levels, Idaho Power seen a 47% reduction in CO2 emissions. And today we don't have any in-state coal-fired plants. Idaho Power, we have a partial interest in 3, one in Oregon, one in Nevada, one in Wyoming. We have plans to shut down 2 of those 3, the plant in Oregon, and then we're actually going to exit the plant in Nevada in the next 7 years. So 2 of our 3 will be out of in the next 7 years. And one of the primary focuses of our current resource planning process is looking at our Wyoming plant, looking at the economics there and the potential future of it. So obviously focused on the environment, carbon. Affordability, so I showed residential rates, how we compared with California. This is commercial rates. Wanted to keep the context. We're talking about Idaho economy. I'm trying to provide kind of the business context. So this is how commercial customer costs compare with some of the surrounding states. See California, Portland, Salt Lake City, and then our Boise rates, 30% below national average there. So when we talk about Idaho economy, we talk about Idaho, the state, competitive advantage. To me, and I'll speak for Idaho Power too, but our affordability, our electricity cost is a major competitive advantage. And so we're certainly trying to keep that. We work tirelessly to keep our costs low. And certainly, that's the focus of our long-term planning is to keep costs affordable for our customers and keep that competitive advantage. Just real quick, want to make a plug. So this year, Idaho Power 7% rate decrease for residential customers. So just want to remind folks there kind of where we are today. Things are looking good. Reliability, so getting to customer satisfaction, where we are today. Last 5 year, our average So an average customer of Idaho Power will experience 1.4 outages per year. Kate, unfortunately, was in a hotel last night downtown that experienced an outage last night, so she got one. Doesn't even live here, so I don't know how that figures into the stats. But, so she had her outage. She got 0.4 more to go, Kate, unfortunately. But actually, 2018, we're trending towards 1.2. So just keep that in context. This is how many outages we see. This is something. Any number up here is probably higher than we'd like to be. This is something we're always looking to improve. That, in other terms, our services, electricity is there for our customers over 99.9% of the time. So we start from a good place. I mean, there's always room for improvement, but just want to provide that context. And so more about some things we're doing at Idaho Power, kind of focusing more or largely on the new technologies in the future. So non-wires opportunities. So we have processes in place where traditional infrastructure upgrades, if we need to upgrade equipment, we upgrade wires, we upgrade transformers. We have processes in place to look at application of solar or storage or some of these new technologies in lieu of traditional upgrades. And one example of that, this is a solar array at the end of a feeder. We call it end of feeder solar. So feeder's a distribution line. So this is in a remote area south of Fairfield, Idaho. We found a pretty unique application where instead of upgrading wires, we were able to put in a solar array, and the output of that array was timed with the period of time where we had the reliability issue. We were experiencing a peak load and had some, so to improve the voltage, instead of putting in new wires, we used a solar facility. So that's just one example. Again, we have processes in place where we're looking at these for all, as alternatives to traditional upgrades. So that's solar. Batteries, we're also looking at battery storage opportunities. There's a small distribution substation in Oregon where we just recently went out to bid. So we had the traditional upgrade. We said, wait a minute, we think we could potentially use storage to offset the peak demand. So reduce that peak demand to where you wouldn't need to upgrade the transformer. This is coming close. It penciled out economically when we put the numbers together based on what we're seeing for some of the market prices for storage. Fortunately, some of the bids are coming back in higher than we forecasted. So as of the last couple weeks, kind of re-looking at if this is going to pencil out specifically, but the takeaway doesn't change. That there are opportunities, and we're starting to see some, as we see prices come down. So there's certainly potential opportunities in the future. Grid modernization, I thought Todd did a great job kind of talking about the system of the future, two-way power flows, and what that takes is two-way communication on our distribution system where we haven't had it traditionally. Smart inverters, smart meters, we have to have everything talking to each other in the system of the future. We've started taking steps in that direction, starting to put in communication infrastructure on our distribution system. And then Kate talked about this. So at a grid level, at the Western system level, utilities working together to better integrate. So this is a map of the Western energy imbalance market. These are the participants, and the focus of the energy imbalance market is so for all that variation within an hour. So you go into an hour and we have this much, we expect this much wind, this much solar, this much load. Inevitably, it's different. It's a forecast. It's going to be off. And so within the hour, utilities are able to pool together and serve that deviation together at a lower cost than they would individually. So looking at a grid level, at a Western interconnection level, ways to keep customer costs low and ability to integrate renewables. So, we had the balanced affordability environment, customer. We do have customer choice. If you want 100% renewable energy, We have what's called a green power program. You can subscribe, and for 1 cent per kilowatt hour premium, you can have 100% renewable energy if you so choose. And so we have a couple thousand customers subscribed to this program. Just want to make everyone aware that there is choice in your service. Future. We see, so Idaho, I think we all know that's one of the fastest growing states in the nation. So with that, we see increasing customer demand. I also mention our plans for our coal-fired facilities. So increasing demand, reduced supply, so we're going to be taking units offline, collectively drives the need for future resources. So that's a heavy focus of my organization. We have a formal process every other year called our Integrated Resource Plan. I see a couple of our advisory council members on our resource advisory council here in the room today, but I would encourage folks to pay attention to this or get involved or come to our meeting. Our next meeting is actually tomorrow, and in fact one of the topics will be our hydro forecast, looking at different climate change futures. And so I think Kate teed it up well. A little teaser is that we're seeing in most models more water over the course of the year, but at different times. So more in the winter and spring, potentially less in the summer. So I don't think that's bad. I don't think that's necessarily good. I think it's just different, and that's just something that we're constantly evaluating the future. And then, like how Kate characterized it well, those are opportunities. They're not necessarily risks or opportunities that exist there. But a little teaser about tomorrow. And I think I'll just conclude there and say, we see a lot of opportunities with some of the new technologies. For us, for Idaho Power, it's about the right approach, it's about the right time, it's about making sure that we balance affordability, reliability, and the environment. But we're certainly excited to be doing this, and this is our job, what we're doing every day. So appreciate you in the room, looking forward to some more discussion.
Thank you so much, Mitch. So our speakers have gotten us off to a great start, a lot of information there for us to dig into. Sometimes we hear people talk about this summary, what you just heard from everybody is this transformation. Our grid is becoming decentralized, so more options, more choices, and then it's becoming decarbonized, so reducing the greenhouse gas emissions, the carbon content of our energy system. So that's more of the larger scale renewables we were talking about. Decentralizing the grid is more microgrids, distributed generation that we've been talking about, as well as home and business on-site systems. And then people talk about it becoming digitalized, so more modernized, digitalized, so that you can have better communications operations. I'm just going to start with one question to the panel, and then really going to be looking to you guys to get your questions ready. As we talk about this transformation, I was wondering if you could just give an example, one or more of you, of where you're seeing this transformation being done well in a state. But they're really being strategic about what are their assets, how do they deploy these new technologies to maximize the job creation, the cost savings, and the reliability to their system. So who's getting it right out there? If you have any examples, whether it's a community or a state, I'd love to hear if any of our panelists have answers to that. And the mic there, I'm hoping is on. Is that mic? Okay. And we're going to hand out more cards to folks too, who can write questions down. And okay, great. I'm going to turn this off. And turn that off.
No, it's on actually.
Where are they doing it and how? What's right about it?
Where are they doing it?
Yeah.
I'm not sure if there's any state that's really doing it well right now. Overall, yeah. I think there's some examples of some communities that are doing some pretty interesting projects, and some utilities that are really kind of getting out on the cutting edge a little bit. But and then the military, there are some good examples in the military of some locations where they're where they're making some pretty good progress in terms of, trying to improve their renewable energy and their resiliency aspects, and integrating some of the controls challenges that we're talking about.
Doing it differently because every state has extremely different resources and extremely different energy demand and economics. And the places where I've seen the best work done are places that are not segregating out energy and environment as a different issue than economic development, but actually combining them. You may remember this in Michigan about when Jennifer Granholm was governor there. She combined her economic and labor and economic department and energy department into one, because of the state being so energy intensive, but also just having all of these issues that they had to figure out from a kind of economic development perspective. I think that's a really smart idea because you start to walk down those paths together. The place I'm going to point to, it's not in the US though, is I do a lot of work in Japan, and Japan's really interesting because for them, these issues are about national security in a very big way because of nuclear plants being on the coast within North Korea missile range, as well as after the tsunami, a bunch of concerns about nuclear, as well as a huge amount of renewable power availability and a shrinking population. So all these things they're putting together in the mix of how to do their sort of next generation of development, and they're spending a lot of time on grid integration, on microgrids, and on thinking about ways to be more secure, given those dynamics. And I think that's important because they're really integrating, again, all of those different elements of geography, economics, security, and not just segregating this out into sort of its own little pocket of conversation.
Let's see, I think I've got a few examples to talk about. With the last slide that I put up was about the control systems and the management systems, and I think we're seeing that actually kind of taken off mostly in California, and actually in Southern California. Southern California Edison and SDG&E both have good programs that are really trying to take that to the next scale where they've got local aggregators. And what an aggregator does is say you've got 10 houses in a neighborhood that all have rooftop PV, and the utility wants to see it more as a centralized resource. So they'll aggregate together the output from those rooftop PVs and then deliver to the utility instead of a whole bunch of 2 kilowatt systems. Here's 20 kilowatts, which is still small for utility, but that's what the aggregators are doing, in case a lot of people aren't familiar with them. But there's a lot going on in California around the aggregation, and a lot with private business. That's really being driven by, like I said, there's a lot of innovation there. As far as just large-scale renewables, nobody does it like Texas. Texas went from 0 to most in about 10 years. And one of the things that I thought was interesting about Texas, they've got so much wind on their line. The reason is they were generating a lot of electricity with natural gas, and then somebody had the bright idea. They're like, why do we want to do this? Why don't we export the natural gas out to those other states, and we'll generate electricity with our wind, and we'll keep that electricity here and make money. So it's a big money-making
One just
opportunity.
on Texas, just really quick. They also have really low curtailment rates. So Texas is a leader globally on the amount of wind they waste. So whereas in China, where I've done a lot of work, it's about a 35 to 40% curtailment rate for wind. A lot of those systems just aren't hooked up to the grid. I'm sure you've all read about this. But also they're just not being balanced. They're not being integrated well. Texas has between a 1% and a 2% curtailment rate most of the year.
Yeah. So and they did that as it was a state choice.
It was
the state
policy.
they built. There's a lot of wind in West Texas. There's a lot of load where the cities are. The population's in East Texas, Houston, and Dallas. And they built this. They built these. They're called CREZ lines. They're large high voltage lines that bring all that wind, the electricity generated by the wind in the West, out to the population. And so they've really done a great job with that. And like I say, they're selling their natural gas out of state now and just making more money. Another one though that I want to bring up is especially about the microgrids back east. So remember Superstorm Sandy a few years ago? There's a lot of solar, there's a lot of rooftop solar in New Jersey and New York, and with the policies, how they have traditionally been, you can only generate electricity with your rooftop solar if the grid was energized. And once the grid went down for some reason, then you had to stop generating electricity, and it's a safety reason. So if somebody from Idaho Power goes out and needs to fix a line somewhere, they don't want electricity from your house being pushed onto the grid because you can hurt somebody. So what they realized after several days of not having electricity back east in New York and New Jersey, and they have all this rooftop solar, and they couldn't use it, and people are like, why do I have that on my roof if I can't generate electricity with it? At the same time, like Kurt mentioned, you know, your diesel generator is great if you got diesel. But once they ran out of fuel and they couldn't get the fuel out because, you know, there was just the whole system shut down. And so there were days when the microgrids weren't working, the critical infrastructure wasn't there. And so they've actually changed policy now in New Jersey, and I'm not sure if they've done it in New York as well, but I know they've done it in New Jersey, where now you have what we've called anti-islanding. Now they have islanding, and islanding is kind of like that microgrid that I showed, where you can detach and operate on your own. And so I think I think other states are going to follow that. But you know, that was something where it was really driven by a big climate event, and they said, well, this is crazy. We should use that solar on our roof. We paid for it, you know, so.
Great. So one of our first questions is, has Idaho Power uncovered in its early smart grid implementation new opportunities for non-wires grid solutions such as solar, wind, and batteries? So beyond the examples that you provided here, has that helped you all identify some new opportunities?
Gotta get the mic.
Sorry.
You can use the other one for half of us.
So we're constantly looking, there's nothing in the hopper now, but what we found is a lot of these opportunities are so unique. I mean, you have to have the right, it's like the right profile at the right time to be served by the resource. What we are doing though, and actually Andres is in the room that's done some of this modeling, is we are trying to get an idea of when. We've looked at different applications of storage, and just like Kurt, I actually really enjoyed when Kurt's up here sharing costs, because that's really informative to us, and it gives us an idea as we do look out to the future. But specific to the question, nothing identified right now, but certainly see more opportunities as costs decline.
Well, on a related question then, there's a lot of questions around storage and the cost of storage, which Kurt did talk about, and we are seeing it really come down quickly. What is it that's going to help get storage there? We, of course, have federal funding for more kind of R&D, commercialization, reduced risk for those early deployments. Is it policy? Is it we just need to continue to acquire it in places where it's more expensive and therefore more cost effective now, and then it'll just bring the price down as we get to scale? Does anybody have any thoughts about what we need to be doing, what we should be asking our policymakers to do to help get that storage so it can help enable more of these technologies to come on faster?
I want to hand it to Kurt, but I guess I do want to go back to just kind of the difference between Idaho and say California. When you look at like what's affordable here versus what's affordable in other places, and we're monitoring. We're seeing some of that play out in these other states. So in Idaho, we do seemingly have the luxury, based on our existing structure and the resources we have in place and our balanced fuel energy mix, to kind of see some things happen and sit back and wait, wait for it to be a good time for us.
Yeah, I think it's a mix of scale, and selling more systems, but it's also, you got to do the research work and invest in that as well, and invest in some of the things that are looking more promising, that aren't. We kind of have to do a mix and a balance of, you don't want to invest in too much stuff that's 25 years down the road. You still want to invest in that, but maybe that's a 5% of your overall R&D investment. Balancing that investment into what makes sense, from a business case perspective. Definitely scaling up the electric vehicle market is really a big driver. So buy an electric vehicle. The more people buy electric vehicles and the more batteries they produce and they start driving costs down, that's one of it. Also these early implementations by utilities, that's driving demand, and that's going to drive more production, and that's going to drive costs down. And you're also starting to see some diversion a little bit between the electric vehicle battery market and the utility use market, because those are really different use cases and You know, on the utility side, I talked about cycle life. We'd like to have a lot more cycle life available. In an electric car, that's not, you know, so much the case. And energy density is super important in the car, but not so much in the utility space. So, you know, we're starting to see some diversion there, and that's going to, you know, when we start seeing more applications and more purchases within microgrids and utilities, you're going to start to see things scale up.
Yeah, I'll go after you.
Great. Just a couple of things on California, two of which I have to just correct Mitch on, since I do a lot of work there and I live there. So one is that our rates are high, but California has among the lowest bills in the nation. So if you actually look at what the consumer pays, which is what the consumer cares about, I know this is not what the utility cares about, but the consumer cares about the bill. Looks like we have very strong efficiency programs and very, very low bills, even given higher temperatures and more air conditioning use in the last year. So that's just an important point about rates. It's important to look at both those things. Also, just a clarification that the bill that just passed, SB 100, is not a 100% renewable bill, it's a 100% clean bill. And that is important. That was very important in the passage of that bill. And it's just, we don't know exactly what that will mean, but it's important just to know that. So going forward. But the last thing about California, I do a lot of work with investors, and I am starting to see a lot of interest from the investment, including the venture investment community on batteries, for a couple of reasons. One is the EV market, and it's just exciting to people. People like it, like the electric vehicle market. It's more interesting to a lot of angel investors in particular than, you know, large-scale utility applications. But also, California has a solar mandate. I mean, not a solar mandate, we have that too, but we have a storage mandate. And the storage mandate has led a lot of people to see a market in the state that's sort of a guaranteed market in the state, which has led to a lot more money flowing into this space. So I do think that's important to kind of signal from the state level that this is a priority.
And I would just say that in Idaho, it's an important note when you talked about the efficiency and the fact that overall California has lower bills because of their efficiency regulations. And in Idaho, I believe we actually rolled back our efficiency requirements for our buildings. So that actually makes us pay higher bills, even though we have lower per kilowatt hour prices. We actually end up paying more because our buildings are less efficient. So when we look at this, we have to look at the whole picture of not just our cost per kilowatt hour, but do we have good efficiency for our buildings, whether it's commercial or residential codes.
Just want to add a little bit more about what we need to do to see more implementation of storage. And I agree with everything Kurt said about the R&D, so I won't repeat it. And I think that policy matters a lot. Kate's right that, you know, California, they've got some storage mandates, so that is obviously driving. In states where there aren't mandates, it's really difficult because in order for a utility to pay for any large asset, any large new generator, line, whatever, they want to rate base it, meaning they want to pass the rates on to you and have you pay for it. And that makes sense. I mean, I want them to do it too. But in order to rate base it, you need to get the Public Utilities Commission to approve it. Public Utilities Commissions in states like Idaho and states that don't have, like most states, I would say, don't really have experience yet with storage. And so they don't understand storage. Public Utilities Commissions, if you think back to my first slide about the old grid, that's their viewpoint. That's what they understand. And there's two types of assets that a utility owns: a generator and a line. And those are the two things. And if it's not a generator or a line, the Public Utilities Commission doesn't know what to do with it. Storage is neither, because storage at times acts like a generator when it's providing electricity to the grid. At times it acts like a load when it's pulling energy off the grid because there's, you know, maybe more solar being produced than is needed at the time. And so a lot of public utility commissions around the nation are struggling trying to figure out, what do we do with this asset? How do we rate base it? We can address the cost. We can know the cost because we can go out and get 3 bids and we go, okay, this is the lowest bid, this is how much it's going to cost to install this. The value is a much harder thing to quantify because we talk about in storage stacked values. There's the value of energy arbitrage, which is essentially buy low and sell high. There's a value of ancillary services, keeping the frequency where it needs to be, keeping the frequency in balance, keeping the voltage in balance, spinning reserves. So if a generator over here goes down, can you quickly ramp up this generator over here to make sure that there's still enough electricity on the grid? all of these things, there's value associated with it, but it's really hard to quantify that until we get to the point where we start using it, we start understanding it more, and we start realizing that, well, we can do all of these things, but we can't necessarily do it all at the same time. So how do we quantify that? And one thing that is nice about having a state like California with the mandates out there, they are starting to understand it, they are figuring it out, and they're certainly not getting it right immediately, but they're figuring it out and they're learning and gaining experience with it. So I think the policy matters, and we can talk about FERC 841 later, anyone who wants to.
Quick Kurt, and then I've got two.
I'll add one more thing. Policy matters, but markets matter too.
That's FERC 841.
Yeah, supply and demand, and just market mechanisms in general. We've done a lot of these projects now with the military where we're putting in batteries, we're putting in microgrids, and we're a lot of times really hamstrung on what we can do, for use cases on some of these assets. If we had market mechanisms to exchange services back and forth with the utility, we could really make a lot better business case on these systems and get more deployed.
So you're saying when the military's not using those assets, being able to actually bring them into the grid and having that relationship
You
between
use them for
the
other grid
military
services
assets,
and having a market mechanism to be able to do that back and forth. We're extremely limited in market mechanisms right now with a lot of these systems.
We had two sets of questions around a couple baseload sources that are more traditionally thought of baseload sources, hydro and nuclear. So in addition to the conversation about renewables, the important role of storage for renewables, but also overall grid services you've just been talking about. Hydro, we had questions around the climate impacts on hydro, how is it being addressed by Idaho Power, batteries, pumping. Someone asked, given our large hydroelectric base, they'd expect more pump storage conversation. Should we be using it more in storage? Does climate change impacts make it less predictable and therefore less potentially usable as storage? And then also, many states don't count hydro in their renewables portfolio standards. So as they're reaching 100% clean energy, is large hydro included? And they were wondering from an environmental standpoint, should it be? So hydro questions.
It's all you, Mitch.
Oh, me, I'm here alone on that one. Let me see if I can sort all this out. So, to the pump storage, and maybe Amy jump in if I'm missing part of the question too, but I'll tackle the pump storage first. It is something we look at. There's been some sites proposed, developers that have come to Idaho Power with some proposed sites. It's something we're monitoring. There's been some proposed sites in Washington and California we're aware of. It is a resource we include. We evaluate in our long-term planning process. Some of the obstacles, based on my understanding of pump storage, has been the permitting. It's challenging to go through the permitting process, and it is pretty expensive. I mean, you're talking about a large resource. The economics need to be there. Generally, they need to be pretty large in size. But it is something we look at. And certainly, if we're talking about storage, we shouldn't exclude pump storage or other potential storage technologies in that. I'm sorry, Amy.
The other one was around, should hydro be included because of the environmental impacts on fisheries or others?
Sure. I don't know that I'm the right person to address that.
All right.
I do know. What's that?
It's mostly included already. Existing hydro is in almost every state's renewable portfolio standard. It's just new hydro.
Grandfathered it in.
Yeah,
but
new
not
hydro
large.
is usually not.
Right.
Yeah.
Right,
So.
because of those concerns.
Can I pick up on the pumped hydro a little bit?
Yeah.
So I am bullish on pumped hydro. I think pumped hydro is great. Obviously, right now the hot topic is lithium-ion batteries, but I firmly believe that there's a place for pumped hydro in our future. And we've got a place, here in Idaho. I think we've got a lot of opportunity because there's a lot of pumping that already goes on. So where pumped hydro makes the most sense to me is those locations where there's already water being pumped up a hill. That water's being stored in a reservoir, typically for irrigation over the course of an irrigation season. In San Diego, they've recently brought on a couple of pumped hydro projects where they were existing, exactly what I just said, except for they weren't for irrigation. They were run by the San Diego County Water Authority. And they pumped the water up the hill, kept the water there to serve the community. What they did with these, one project's built and the other one I think is under construction now. and they came to an agreement where they said, okay, every Sunday the water's, Sunday at 5 o'clock, the water level is here. Next Sunday at 5 o'clock, the water level will be here. Keep ticking down one Sunday at a time over the course of the season. We don't care what you do with that between Sunday and Sunday. You can use it any way you want. And so they were using the water, to integrate renewables. There's a lot of wind in Southern California, and so they're using this existing asset. It was much easier to permit. The infrastructure is already there. What you're doing is essentially replacing a one-way pump with a variable frequency pump generator, and there's opportunities for that here in Idaho. I think we missed an opportunity at Bell Rapids where it would have been great to put something like that in at Bell Rapids, but instead all that infrastructure got torn out. So that's opportunity lost, but hopefully we don't squander more of those because we do have opportunity for pumped hydro here in Idaho.
I've got two. So there's the nuclear question, and then one more set of questions that I do want to get to, and then we're going to wrap so we can have networking and more one-on-one conversations with our panelists. But related questions: what's the future need for next generation nuclear? Do we need it for baseload power? Is it too expensive to compete in the U.S.? And then what's the timeline related, obviously? What's the timeline for commercial use of advanced small modular nuclear reactors? So,
Good question.
great. Anyone who's going to take the
Yeah, I can start on that.
Yeah.
I think the opportunity is definitely there. The big challenge with nuclear, lately has been cost and managing of construction of these really large, complex, systems. That's been a huge challenge. I have a little bit different perspective than the folks on the nuclear side of the house. Cost is a big driver for us, and so we're always harping on that. But with the small modular reactors, maybe you can get, skirt some of those big challenges like that with, really complex construction and make it more manageable. Bite off smaller chunks instead of these, huge, massive investments. So that's interesting, but I think, we're going to have to see those go into higher price markets first, like Alaska and back at places on the East Coast and stuff to really get some experience and start to scale up. And they're going to have to go through the same thing that we're thinking with batteries, try to get more deployments, more scale, more experience, and make it cookie cutter.
So you see about 5 or 10 years behind batteries as far as competitiveness, or Kate or somebody else want to jump in?
It's just, I completely agree with all of that. It's nuclear is just inherently incredibly complicated to get to pilot and develop because it's such a regulatory morass for good reason. It's a dangerous technology, right? If not deployed well. But there are Terrestrial Energy as a company that has now actually gotten through that process in Canada and is starting to do some of these demonstrations with small scale reactors. There's a real opportunity for them to be integrated into some of these microgrid and regional grid conversations. I just personally, I can't see another big nuclear plant being built in the United States anytime soon. It's just too expensive, and the waste issue is the other big issue. There's a big political issue around waste, there's a big issue around cost. There's too much other stuff that's cheaper. And it's not gonna happen. It's one of the reasons SB 100 passed in California that there was a set of people who said, what doesn't that mean nuclear is included if it's clean and not renewable? And the bottom line on it was no one's ever going to build another nuclear plant in California. So it didn't matter at the end of the day politically that was true. And I think we're going to see that more and more.
So SMRs potentially, but no one's weighing in on the timeline.
We're not there yet. I mean, I think, yes, we're behind batteries, don't you think, on small scale reactors? By 10 years, probably.
So it gives you a little bit of a range there. And then the final, sorry, we'll wrap this quickly, but it's important. It's about, given really the costs of and the speed at which we're integrating these technologies and when it comes to climate, the need for climate, but also the need for our economies to benefit from these technologies. So given the demise of the Clean Power Plant, our market forces enough to drive the conversion to low carbon or no carbon sources at the pace needed to avert the worst of Kate's graphs about climate impacts. And for Mitch, more specifically, as you reduce the reliance on coal, how you make decisions about what you close, when and how, and does that include a price on carbon? Is that predicted at any time frame as you consider those costs?
I'll do a really short beginning on that. That's a big question, but
yeah.
The reality is that it will not happen as fast as we needed to get to 1.5 degree warming, for instance. The political processes and economic processes are clunky and hard, and we're talking about economic transformation. It's a lot a lot of pieces. That means resilience is really important, and I just would echo that again, what Kurt was talking about, that there is a big piece of this that's just about being more secure and resilient in the face of some of the existing impacts and the existing emissions. But in terms of our market forces moving, they are completely moving. I mean, I talked about this last night, but coal has come way down in as a percent of our US energy mix in large part because of market forces, because natural gas came online and was a lot cheaper, and because renewables got so much cheaper. Those are the two reasons that coal is going down there. It's not about a war on coal, it's about the market. People making decisions that are market-based. The region, the Western region, California obviously has all these policies. Oregon and Washington are developing a lot of policies. The Western region is a leader on this stuff and is creating a giant market for most of it, which Idaho is very proximate to. So that's something. Around the world, 20 countries and 40 jurisdictions have prices on carbon now. Those are only getting higher, and people are increasingly putting, and the thing I should have talked about, putting prices on negative emissions as well. So carbon removal is becoming more and more valuable, another place where Idaho has a real advantage. So the market, in some ways, despite whatever's happening at individual state levels, the market is changing all around, and this train is moving. And I just think it's not moving as fast as the climate scientists would like it to move because of the reality of politics, but it is absolutely moving.
I'd like to just touch on the cost a little bit, and I'll pass it over. The important thing to think about with cost is not what's the cost of the electric generators that are out there today, not what's the cost of electricity from Hell's Canyon or Bridger. The important thing to think about with cost is what's the cost of the next new asset that we bring online. And pretty much in most places in the nation right now, wind and solar are the lowest cost alternatives, unsubsidized. Subsidies just make it more so, but subsidies are going away for wind and probably for solar as well. But on an unsubsidized basis, right now in the Midwest of the US, wind is the cheapest, there's no question. In most of the desert Southwest, solar is the least cost alternative. So if you're just looking at pure cost, renewables are certainly leading the way.
What's really interesting to a lot of folks around our lab is as we get higher and higher penetrations of variable generation, the longer duration storage question, the cost, nuclear base load mixed in there, alternative thing, integrating in EVs and managing that in the system, using that as a flexible resource. Industrial processes, hydrogen for making steel, all those types of things are really interesting, longer term as we start to get, above 50%, 60% penetration of variable generation. And so that's kind of what a lot of our people are thinking about on the horizon. There are these really challenging things, trying to shift energy from here to here over long durations.
Yeah, I think it's pretty interesting, the analysis as we look at unit shutdowns. I mean, we're not just talking energy. I mean, we're talking about what we talked about earlier, some of the reserve capability, the flexible, the ramping. I mean, there's characteristics of some of these existing facilities that we need to account for in a replacement. And, a lot of the costs we see with the resources, with the wind and solar don't always account for some of those other value streams and what's needed to operate a system. So, wind, 30% capacity factor over a course of a year, meaning 70% of the time we need another resource. Solar, 20 to 30, meaning we need another resource 70 to 80% of the time. And then handling the ramps and intermittency, it's in our evaluation, we have to account for a resource being there when you need it. And certainly storage, we've had the conversation today, storage is a great example of that. There are limits, like the 4-hour duration is kind of what you hear today, but there are limits to what it can provide and how much of the year. But to your question, Amy, or to the question asked, we do need to consider more than just the variable cost of replacement resources. And to the question about what we see, it really is economics as much as anything. We see it happening. We see the cost of renewables as they compare. So there's certainly we see the transition. We're part of it. We're in the middle of it. We're we're trying to, again, back to the kind of the balanced approach, we have to keep reliability in mind as we do transition. So that is a major element when we do look at these shutdowns and potential replacements, is keeping the lights on. So I think we can do that. It's kind of hard. We talked about the market mechanisms and kind of the values for storage. It'll happen. It's not all the way there yet, all the value streams for it, but.
Hydro already on the system, given that we have so much hydro,
Yeah.
can it help a lot with that?
Good
Because it's
point.
already there?
We're fortunate in Idaho, like our hydro base allows us to integrate the amount of renewables we have. We have Idaho Power System, we have over 1,000 megawatts of wind and solar. Our peak demand is 3,400 megawatts, so 3.4 gigawatts, and we have 1,000 of wind and solar. And the reason we're able to do that is because of our hydro base. So the hydro really, really helps on multiple levels, really.
And then, of course, there's all the renewables, I guess, that we could potentially export to other places. And
And geothermal.
We haven't even talked about geothermal. All right, with that, we're going to wrap it up, but I think just to throw some thoughts out there. So I think we heard from folks that buying electric vehicles as individuals, as fleet owners, if you own businesses, et cetera, is a great way to help move some of these markets forward. But also think about what this means for our key industries here, the leading industries that we have, the tech industry, the healthcare industry, agricultural users, water pumping. Where are those opportunities for our key industries where it's not just creating new energy jobs, but it's also creating opportunities for those industries to be more competitive by potentially integrating and or keeping the hospital's lights on in times when we need them to be on. So pretty exciting time, complicated issue. Thank you so much to our panel for helping us to understand where we are, where we can go, what needs to happen. Please join me in thanking them and thank all of you.